Hello, in this video, we're going to be talking about right triangle trigonometry. We're going to learn how to find the trigonometric functions of acute angles. Okay, we're going to evaluate trig functions, find unknown side lengths and angle measures, and also use our trig functions to solve real-life problems. Now, you may remember from geometry class, we talked about SOHCAHTOA. This is the way that I like to write SOHCAHTOA. Okay, because this way I can tell that sine of an angle is opposite over hypotenuse, cosine of an angle is adjacent over hypotenuse, and tangent of an angle is opposite over adjacent. Okay, you may remember that from your geometry class. However, did you know that there are actually 6 trig functions that we're going to be talking about? Okay, so as a refresher, sine of an angle, notice I have the angle measure there, equals this fraction. Sine is opposite over hypotenuse. Well, opposite of what and hypotenuse compared to what? Opposite of this angle right here, right? This angle right here, theta is a Greek letter, is opposite this side. So we're talking about the length of this side being opposite to this angle, okay? And then hypotenuse is the hypotenuse no matter where our angle is, okay? Cosine of an angle, cosine is going to be the length of the adjacent side over the hypotenuse. Okay, adjacent is a fancy word that means next to. Okay, and then tangent is going to be the length of the opposite side over the length of the adjacent side. Okay, so that we get from SOHCAHTOA, if you remember. Let me write it down again. This is the shorter way of writing it down. SOHCAHTOA, right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, okay? The other 3 trig functions are actually based upon these 3, sine, cosine, and tangent. So the other 3 trig functions are going to be cosecant, secant, and cotangent. Okay, now cosecant, we abbreviate that CSC of theta, is 1 over sine of theta. So cosecant is the reciprocal of sine, okay? So the reciprocal of sine, reciprocal meaning I flip my fraction, the reciprocal of sine is going to be the hypotenuse over the opposite, okay? Next we have secant. Secant is going to be, secant of theta is 1 over cosine of theta, and secant is going to be the reciprocal of cosine. So cosine and secant are kind of partners like that, okay? So secant of theta, I could say it's 1 over cosine of theta, or I can write it as a fraction with the reciprocal of cosine, and that would be hypotenuse. That would be the hypotenuse over the adjacent, okay? And then finally, we have tangent, and its partner is cotangent, okay? Tangent of theta is opposite over adjacent. Cotangent of theta is going to be 1 over tangent, so it's the reciprocal of tangent. And if I do the reciprocal of opposite over adjacent, the reciprocal of opposite over adjacent is going to be adjacent over opposite. I would recommend pausing the screen right here and writing all of these down. All right, so let's evaluate the trig functions. We want to evaluate all 6 trig functions of this angle theta. Okay, in order to evaluate all 6 of my trig functions, I need to know all 3 sides. Right now, I only have 2 sides. I have this leg of 5 and this leg of 12. I am missing the hypotenuse. So in order to find out the hypotenuse, I'm going to use the Pythagorean theorem. Remember, that's a squared plus b squared equals c squared. So we're going to do 5 squared plus 12 squared equals the hypotenuse squared. Okay, when we square 5, square 12, add those together and square root, we find out that the hypotenuse has a length of 13. So this is 13. Okay, now what I want to do is I want to evaluate the 6 trig functions of this angle theta right here. So that means that this down here is the opposite, this angle right here, or this side right here is adjacent, and this side is the hypotenuse like we've already established. Okay, so sine of theta is going to be opposite over hypotenuse, so that's going to be 12 over 13. Cosine of theta is going to be adjacent over hypotenuse, so that's going to be 5 over 13. And tangent of theta is going to be opposite over adjacent, so that's going to be 12 over 5. The other 3 trig functions are going to be cosecant of theta. That's going to be the reciprocal of sine, so that's just 13 over 12. Secant of theta, well, that's just going to be the reciprocal of cosine, so that's going to be 13 over 5. And then cotangent of theta is going to be the reciprocal of tangent, so that's going to be 5 over 12. And if you'll notice, sine and cosecant, they do not start with the same letter. So that's kind of like a little cheater way of how to remember what goes with what. Sine and cosecant, they don't start with the same letter, so they go together. Cosine and secant go together. And then tangent and cotangent, they go together. Okay, our next example, we have a right triangle. In a right triangle, theta is an acute angle, and sine of theta is 4 over 7. Evaluate the other 5 trigonometric functions of theta. Well, in order to do that, it's helpful to have a triangle sketched out. So I'm going to sketch out a right triangle. That's my right triangle. I'm going to say that this is my angle theta. Okay, sine, if you remember, is going to be opposite over hypotenuse. So opposite of this angle, this is 4. And the hypotenuse, right, so across from my right angle, this is going to be 7. Now, I need to know that third angle, that third side, so that I can evaluate the other trig functions, right? So again, I'm going to use the Pythagorean theorem. I'm going to find this side right here. I'm going to call it b for now. So 4 squared plus b squared is going to be 7 squared. Okay, when you square 4, you get 16. Square 7, you get 49. Subtract those, you get 33. So b squared is going to be 33. And b is going to be the square root of 33. Okay, so I know that this b is the square root of 33. Okay, so now in order to find my other trig functions, well, cosecant is pretty easy because cosecant is just the reciprocal of sine. So that's going to be 7 over 4. Okay, so I need the other ones. I need cosine of theta. Cosine is going to be this adjacent over hypotenuse. So that's going to be the square root of 33 over 7. And then tangent of theta is going to be opposite over adjacent, and that's going to be 4 over the square root of 33. Well, I don't leave a square root in the denominator of my fraction, so I need to multiply the numerator and the denominator by the square root of 33, and that's going to turn this into 4 square root 33 over 33. Okay, now for the other trig functions, I've got the secant of theta. Well, that's just the reciprocal of cosine, so that's going to be 7 over the square root of 33, except it's not because I can't leave a radical in the denominator, so this is going to be 7 square root 33 over 33. And then cotangent of theta is going to be the reciprocal of tangent. So that's just going to be the square root of 33 over 4, and that one's cool because the radical is not in the denominator. All right, next we have trig ratios for special angles. Now, if you recall from your geometry class, we have special triangles, special right triangles being this 30, 60, 90 triangle, okay? However long your hypotenuse is, you divide that by 2 to get the short leg. You take the short leg times square root of 3 to get the long leg. And then we have this 45, 45, 90 triangle. The two legs are exactly the same, and you take that, multiply it by the square root of 2 to get the hypotenuse. Okay, well, it doesn't matter how big or small your triangle is, as long as you have 30 degrees and 60 degrees, this pattern works. And as long as you have 45 degrees and 45 degrees, this pattern works. Okay, if I were you, I would take a moment to pause the video and copy down this table right here with the sine, cosine, tangent, cosecant, secant, and cotangent ratios for a 30-degree angle, a 45-degree angle, and also a 60-degree angle. Okay, thank you. Now we're going to find unknown side lengths. We can find the value of x for this right triangle by a couple of ways. Okay, I could, if I want to, say, okay, this angle is 30 degrees and I'm trying to find this side x. Well, that's adjacent. And I know this side right here is 8, and that's the hypotenuse. So I could go to SOHCAHTOA and know that the cosine ratio uses adjacent and hypotenuse. So the cosine of 30 degrees is going to be adjacent x over the hypotenuse 8. I could pull out a calculator and figure that out, or I could use what I know about special right triangles. This is a 30, 60, 90 triangle. The hypotenuse is 8, which makes the short leg 4, which makes this long leg equal to 4 times the square root of 3. So x is simply going to be 4 times the square root of 3. And that's so much faster than pulling out a calculator. All right, now in this example, we want to do what is called solve triangle ABC. Now this word solve means find all of the missing angle measures and all of the missing side lengths. So we need to find the measure of angle B, we need to find the length of side little a, and we need to find little c, because we already know angle A, that's a capital. We know that C is a right angle, and we know that this side down here is 15 units long. We just don't know angle B, we don't know side little a, and we don't know side little c, okay? So in order to do that, I'm going to use this 28-degree angle, and this side right here is going to be the adjacent, okay? This would be the hypotenuse. This would be the opposite. Okay, I'm going to go ahead and use, I could do adjacent over hypotenuse and do 15 over c, and that's going to be the cosine of 28 degrees. Or I can do opposite over adjacent, which is tangent, and do tangent of 28 degree is a over 15. I'm going to go ahead and use tangent. So the tangent of 28 degrees is opposite over adjacent. If I multiply both sides of this equation by 15 times 15, I can cancel out that denominator. And in my calculator, what I'm just going to type is going to be 15 times the tangent of 28 degrees. And that's going to give me that A is 7.9756. You can use as many decimals as you want to. Okay, and then I can use A and B in order to find C, the hypotenuse, because I've got the Pythagorean theorem, right? So I could do 7.9756 squared plus 15 squared equals C squared. When you square and add and then square root, you're going to find out that the length of C is approximately 16.99. Now you have to read the directions in your problem. Okay, if it says round to the nearest whole number, you could round A to just 8. You could round C to just 17. Okay, we still haven't found the measure of angle B. Well, that's probably the easiest one to find. I know that this is a 90-degree angle and this is a 28-degree angle. So the remaining angle, that needs to be big enough to where the three angles add up to 180. Really, all I'm going to do is 90 minus 28 degrees, and that's going to be 62. That's a 2. So B, the measure of angle B is going to be 62 degrees. Remember to put the degree mark there, because if you don't, you're measuring in a different unit. All right, so how might we apply these trig ratios? We're going to use indirect measurement on this problem. You are hiking near a canyon. While standing at A, so this point right here, you measure an angle of 90 degrees between point C on the other side of the canyon and this point B. Then you walk to point B and you measure an angle of 76 degrees between where you were first, point A, and across the canyon at point C. Okay, that distance that you walked is a full 2 miles. This is a 76-degree angle. Okay, that's a very large angle. So I'm guessing that this X right here is very large, right? Much larger than 2 miles across the width of this canyon. Okay, the distance between A and B is about 2 miles. How wide is the canyon between A and C? Okay, so according to this picture that we've got set up, we have the 76-degree angle. 2 miles is the side that's adjacent to your angle in reference. And then X is going to be the side that is opposite to your angle in reference. So the trig ratio that uses adjacent and opposite is going to be tangent. So tangent of some angle theta is opposite over adjacent. We put our angle, our reference angle of 76 degrees in there, so that means that tangent of 76 degrees is going to be opposite over adjacent is 2, okay? When you multiply both sides of this equation by 2, you see that this cancels the denominator, and we can find out, we can just plug x into this 2 times tangent of 76 into your calculator, and you find out that x is going to be 8.02, so approximately 8 miles across this canyon. So about 8 miles. And finally, we have this problem right here. A parasailer is attached to a boat with a rope 72 feet long. The angle of elevation from the boat to the parasailer is 28 degrees. And if you're not sure what a parasailer is this guy that's attached to a boat. This boat would be like on a very large lake, and the boat is driving, which causes this parachute right here to fill with wind, and it brings this person up above the water. I hear it's quite fun. It's on my bucket list. Okay. If you were some person standing clear out here, you know, maybe in a boat on the water or on the beach or something, looking at this person, what you would see is this little person up in the air above the water, right? So here's your parasailer, here's your boat, and the rope that is attaching them is 72 feet long, right? The angle of elevation, and now elevation means looking up at something, okay? So this angle of elevation right here is 28 degrees. And the part that we're trying to find is the height of this parasailer, right? So that's going to be h right here. Now, if we use our 28-degree angle as our reference angle, this h is actually the side opposite, and this 72 feet, well, I can see that this is a right angle, so that makes the 72 feet. The longest side across from the right angle is the hypotenuse. Okay, and now I'm going to go to my trig ratio that uses opposite and hypotenuse. That's going to be sine of my angle theta is opposite over hypotenuse. And I plug in the values that I know that I have. So sine of 28 degrees is going to be the opposite is h, and the hypotenuse is 72 feet. Okay, again, if I take and multiply both sides of this equation by that denominator of 72, then what I get is this this string right here, 72 times sine of 28 degrees, which I can just plug that in the calculator. And we find h is approximately 33.8 feet above the water. So that's how high this parasailer is above the water. Thank you for watching.